Hi, my name's Matt, and I'll be walking you through some thoughts on how to size your infrastructure. This video will go over some of the tips and steps outlined in our blog on sizing infrastructure for Tyk, which should help give you some ideas on how to best proceed with infrastructure sizing. Whether sizing for Tyk or other components in your architecture, we hope that you'll find this quick video helpful. And with that being said, let's get started. Firstly, sizing your infrastructure is part science and part optimism. Being sure that it is sized to enable growth while also keeping down costs is a challenge that all organizations go through. Using careful analysis of system metrics and/or smart sizing guidelines, you can optimize your infrastructure for growth and optimize costs associated with your infrastructure. Optimism will allow you to think about your future needs, the future needs of your system, and user-based growth, while metrics and research will allow you to stay within your reasonable bounds. If you go too big, then you'll likely run into large and unnecessary costs, but going too small could lead to high latency, performance issues, and ultimately unhappy customers. In this video, we'll take a high-level look at using the flexibility of cloud providers to size your infrastructure correctly for Tyk and any other components you are deploying into the cloud. By the end of this video, you will walk away with some key considerations when thinking about infrastructure sizing. So what steps will we follow? Well, we will follow a few steps in order to help us drill down into sizing our infrastructure. Firstly, we'll take a look at a few ways we can determine our baseline needs, so what infrastructure we need to get started and have performance where we need it. Secondly, we'll look at some ways we can estimate future needs and growth. So as we scale, we want to make sure that we can continue to meet the needs of our growing user base. Thirdly, we will look at the power and risks of utilizing auto-scaling in the cloud, and we'll focus on when it's a great tool and also how it can add to your monthly costs if not fully thought out. And lastly, we will discuss how to use monitoring and reporting to look for cost savings. So these topics should give you a great idea about where to get started, how to optimize your infrastructure, and possibly point out a few areas where you can save some operational dollars. So to start off, let's first take a look at getting a baseline for our initial infrastructure. So a baseline can be developed differently depending on which scenario you belong to. So maybe you have an existing app with existing traffic, or maybe you have a brand new app with no history. If you do have some traffic data, you can use these metrics to figure out your average latency and requests per second that you're currently experiencing. This will let you know the current load and expectations for your infrastructure. Now, if you only have your requests per second metrics without any idea about latency, then you're going to want to dig into our blog and our manual for simple performance testing with Tyk. Doing this exercise should allow you to determine your average latency. And if you have no traffic currently, you will have to make an educated guess. So doing some research into your application's flows and anticipated user base at launch should help with this. And this should be done based on your best guess. So we also want to make sure though that we're careful not to go too high or too low. You're going to need to find a realistic range that you're comfortable with. So one very important thing is to be realistic at this stage. If you have no data, then you need to make sure to pay attention to this. If your brand new app has no users and is not an API call intensive app, then provisioning infrastructure that can handle 10,000 requests per second with sub-millisecond latency is definitely overkill. It's apparent that you don't want to go too small with your infrastructure, but at this stage with minimal traffic, it shouldn't be too big of a worry. So at this stage, when you're determining your baseline, you can also look at where these requests are coming from. If you have a global user base, you may look to spin up infrastructure in different regions, depending on your use case. You may also look at how you will split up your traffic, like will you run multiple smaller servers in dispersed regions, or pick a few central locations and run larger servers within those. It's useful to play with different scenarios, load test each, and determine which is your best starting point. So after doing so, check your costs. Can you scale down some of your infrastructure and save a few dollars? Remember to look for cost savings that won't impact your customers' usage or expectations of the system. Our next step is to take a look at our infrastructure roadmap and figure out what infrastructure we're going to need in the future. So regardless of whether you're a new application or an existing one, you're going to be doing some estimating at this stage. So some scenarios may make these estimations easier, like if your business has an initiative to double your current user base in X amount of months or years. In this example, you'd like to be able to whip up some simulations for this and ensure that your system still performs well with your newly scaled and sized infrastructure. With a back office application, this may be possible since new users coming on board is more of a predictable thing. However, what if you've built an external system and you're unsure of your future needs? Or what if you have a new system with undefined numbers around user growth and adoption? For scenarios like these, it may be advantageous to look at companies similar to yours and their user base load and growth. If you can get access to those numbers, this is going to help you a lot. A degree of smart optimism will help at this stage since it does require some guesswork. You want to make sure that you're being optimistic and looking obviously to a very, very positive future, but you also want to be smart about it too so that you're not racking up huge cloud bills. So let's start by creating a plan on how you will scale. So first, based on your system and customer needs, consider what infrastructure you will need to double, triple, quadruple, and so on your user base. Then put together a formal plan which outlines your expected growth, the infrastructure needed to support that, and the cost of said infrastructure. After this is determined, you can use this plan to shop across cloud providers to see which one will be the best fit for your use case, based on features and cost. Now that you have some numbers and ideas around your infrastructure requirements, you will want to execute some load tests by spinning up this anticipated infrastructure and ensuring that it can handle the expected traffic. You'll also want to use these tests to make sure that you haven't went overboard either, which will lead to more monthly costs without any benefit. Our next step here is to take a look at auto scaling. So one amazing feature of being on cloud infrastructure is the ability to auto scale your infrastructure. And that helps with increased or decreased server loads. Although it does come with its drawbacks, which we'll also discuss here, most public cloud providers allow you to automatically scale based on specific conditions such as requests per second, CPU utilization, a timed schedule, or a combination of any of these. And this gives us some real benefits in terms of costs and performance. So as part of this strategy, most cloud providers allow for auto scaling groups, which allow us to set limits and parameters for when scaling events occur. It's still important though to make sure that you still size your instances accordingly and not fully rely on auto scaling to solve all of your potential increases or decreases in traffic. This is because even though scaling does happen quickly, there is still a delay in spinning up new instances before they become operational, and data used to trigger these events can also be less than perfect. For instance, by default in AWS, if you're scaling, it's going to be calculated off metrics within the past 5 minutes, and that's the default. This means a large spike in load may not be offloaded to the new resources in a timely enough manner to reduce the impact on consumers' increased requests. Most services also offer, for a charge, a shorter metrics window. So AWS you can actually pull down to 1 minute, which is definitely going to help you out, but it does come with a cost. And this allows for more reactive scaling, although it comes with its own challenges too, because now your average is based on 1 minute instead of 5. So you may see more ups and downs in these auto scaling events. When debating where to set the limits of your auto-scaling groups, it's useful to use your baseline as your starting point for the minimum infrastructure requirements, and then set your upper limits slightly higher than your projected future needs. This should cover you for most of the scenarios that you'll encounter, especially if you've done it following the steps that we mentioned before. You're also going to want to make sure to pay attention to the size of the servers you're using, even if you'll be using the auto-scale functionality. So we may think it would be common sense to use the cheapest and smallest server and then run our operation off that and scale up as we need. But that's not really the best scenario. So our best bet is to find the server configuration that handles our needs the bulk of the time. And while also being conscious of cost, we want to set up scaling to handle any peaks in activity. If scaling events are happening extremely frequently, this may indicate it's time to go back to our first step and reassess our baseline with this new traffic data in hand. Another factor to keep in mind is the stabilization and cooldown period that an auto-scaled architecture experiences during scaling events. So if your setup begins to spin up a server, it will likely remain active for a set period of time, which is sometimes referred to as a stabilization period. So for example, on Google Cloud Platform, the stabilization period defaults to 10 minutes currently. So even if the server is brought up and not needed, it's still going to run for 10 minutes on GCP. And this is going to add to your monthly charges. The cooldown period, where the server is being ramped down post-stabilization period, can last a few minutes as well, which also adds to monthly cost. Having these events occur across multiple scaling groups multiple times per day could lead to a very costly surprise at the end of the month. So it's very good to be aware of these things. So using auto-scaling as a supplement to good infrastructure sizing practices will definitely help to make sure your infrastructure is handling your application and user needs, but be mindful of some of the topics that we mentioned in this slide. We want to make sure that we're conscious of the auto-scaling downsides as well. And our last piece here is monitoring for cost savings. So one of the simplest and best ways to save money on your infrastructure costs is to look at reports from your cloud provider. So by looking at CPU usage, you can easily see trends, including whether you have overestimated your traffic, which is leading to a higher infrastructure cost than required. So it's good practice to inspect your usage statistics regularly. As time progresses and more data is gathered on your usage, you'll want to schedule periodic checks to make sure that your performance and costs are being optimized. So the frequency of when you do that all depends on how your operation is set up and what the needs of your organization are. The key takeaway here is that monitoring usage is an effective way to make sure that dollars you are spending on infrastructure are being well utilized. You may also want to set up automatic notifications for scaling and other infrastructure events that your cloud provider offers, and these vary between providers. But even if you're monitoring your usage daily, you'll at least be aware of these events occurring. So even if you're not looking at things day to day, you're still going to get these emails and notifications that are going to let you know that these events are happening. So this can be a huge help when it comes to monitoring the status of your auto-scaling infrastructure. So great monitoring and reporting can also help with planning out future infrastructure needs, since you're now going to have some historical records to base your assumptions from. All right, well, let's wrap up. So now that we've looked at sizing your infrastructure, you can apply this knowledge to your Tyk API gateway and other infrastructure within your organization. You'll likely also want to check out our benchmarks documentation, which explains server costs and performance on AWS. With these tips in mind, you should now be able to accurately size your infrastructure for Tyk along with other components of your system. So by using some or all of these above mentioned tactics, you should be in a good spot. Being smart and realistic with your infrastructure sizing requirements is an impressive way to maintain a lean budget or cut down operating costs while keeping users happy. So thanks for watching, and we hope to see you tune in again soon.